Welcome to another VMK in the OpenGL Tips and Tricks series. In a previous VMK, I showed you how to load up sprites and render them to the screen. However, you didn't really have very much control over those sprites in terms of being able to move them yourself. The motion of the snowflakes was pre-programmed with an equation to cause the snowflakes to fall downward. On this VMK, what I'm going to show you how to do is to intercept key presses from the keyboard and use those to control the motion of a sprite on the screen. Also, anytime you deal with sprites, you should try to encapsulate your sprite code into a class so that your sprites are compact and you can reuse your sprite code whenever you're moving from one project to another. So let's jump into Photoshop to take a look at the new resources that are available with this VMK. I've included two TGA files. There's this one here called grass.tga, which is a 1024 by 1024 image of a road down the middle and then two grassy boulevards on both sides. What we're going to do is render this as our background, so instead of having the snowman with the girl on the screen, we're going to have this image in the background. Then in the foreground, you're going to have a car that you'll be able to control that drives on that road. Now notice that this car found inside of the car.tga file, it only occupies the bottom half of this 512 by 512 image. The background of this image, which is white as you can see here, is actually not going to render to the screen because I've created a mask channel inside of this image. So you can see here anything that's white will be renderable and anything that's black will be transparent. So only the car here will be visible. None of the white sections of this image will be rendered to the screen. Okay, so we have these two images, car.tga and grass.tga. So let's go into our code and load these into memory. First thing we need to do is open up our scene class. Well, actually, before we do that, I guess we need to make sure that we take those two TGA files and just put them under the build resources and textures folder. So that's what I just did there. And now we can go in and load those images. So inside of our scene class, we want to take a look, well, let's load up our header file and scroll down to the bottom because we've defined this std vector for snow. We won't be needing him, so we can just comment that out. And let's take a look at where we initialized this guy here, because this is what we're using for the background image previously. So we're looking for him inside of our scene class, and it should pop out. Oh, here it is, loading our snow. Okay, so we're inside of the initialize function found inside a scene, and we can see here that we are loading texture snow.tga. So let's just change this to be grass.tga. What I want to do is comment out all the code pertaining to the previous VMK. So I won't be initializing any of the snow here, and when we are rendering, the render code was found inside a GUI render. So I can go into here, let's see, we want to still enable the textures, we want to draw the background. This time it's going to be drawing the grass and the road. This stuff here is okay, and then we can comment this for loop out since we're not going to have any snow. Okay, let's try building this and see what happens. Okay, let's give this a run. Alright, so there we go. We have a static image for our background. We have just the road and the grass on both sides. Now let's load in our car. But before we do that, I want to create a car class which will contain all the specific information about the car. So how to render it, how to move it, things like that. Now normally you'd create a separate CPP file and header file, name it car, and add it into your object lib or something like that. However, because this is just a quick demo of how to control sprites, I'm just going to put it right here inside of the scene header file and use it all directly like this. If you are building a larger project where you're going to be using all these different kinds of sprites, I highly recommend you separate your code out so that you can then easily copy it over into different projects later on. Okay, so here's our car definition. We have a enumeration at the top which is going to indicate which direction we can move the car. We have forward, back, left, and right. The car constructor, we have two variables inside of the, or actually we have three variables inside of the car class. We have our bind texture, so this is a texture that's associated with the car. We have how fast the car can move, and where is its current location on the screen. So inside of the constructor, I'm going to initialize the speed of it to be 200 pixels per second, and the initial position is somewhere centered and down a little bit. So because we're at 1024 wide for our screen, then halfway is 512 and 300 is just some number I arbitrarily chose. We have a function here called assign texture, which we use to assign a texture ID number to our car class. You can see that whatever I pass into here just gets saved as our member variable. We have a render function, which we call to render this car to the screen. We enable the texture, we bind the texture ID to our value that's stored inside of our member variable, and then we need to position our car on the screen somewhere. So we use the model view matrix, we set the translate coordinates for the x, the y, and z we're only setting to 0 here because we're only working in 2 dimensions. And then we need to specify our texture coordinates and our vertex coordinates to draw the car on the screen. And then after we're done that, we can disable our textures. So that's pretty much the whole car class. Now let's go into our scene class, and at the very bottom, let's add a car object, like so. And inside of our scene initialize, let's go and initialize some parameters for that car. Actually, I'll just delete this code since I won't be needing it, and replace it with the following. So we're going to use another texture this time, and we're going to load a texture into our scene class. So we specify resources, textures, car.tga, but the ID number that this function returns to us, we want to pass into our assign texture function call inside of our car class. So whatever we save here is going to automatically get saved inside of our car class. Now that we have that, we can go inside of our GUI render function, and after we draw the road, we want to draw our car. So let's delete this and just call mcar render. Okay, let's see what this looks like. Okay, so there we go. We see we have our car sort of half off the screen and somewhat centered on the screen as well. Now what I want to do is allow the arrow keys to move the car forward, back, left, and right. Oh, I just noticed that I put my render function call before disabling this texture here. This actually should have gone after the GL disable, because we want to disable the textures here, which is associated with this enable here, and the render function call inside of here has its own GL disable GL texture 2D. It didn't bring up an error because really we're just toggling a flag, but to keep things correct, you should actually have your code written this way. Alright, so now to move the car, we can do the following. We have all the keys getting stored inside of our user settings class. So just by looking at the B keys values, we can then decide how we want to move the car. So what I want to do now is create a move function call that's going to belong to the car, and we can specify which direction we want to move the car in and how much time has elapsed. This time that has elapsed will be used to calculate how far to move the car. See here we have, if we press the up arrow key, we're going to be moving forward. You press the down arrow key, we're going to move back. Left will move the car left, and right will move the car right. So let's go implement this move function call inside of the car class. I'll put it here before the render function. We're passing in the direction we want to move the car in and how much time has elapsed. We have a switch statement here which will go into the appropriate case statement. If we're moving forward, then what we want to do is update the y coordinate for our position. Same thing if we're moving back, we only update the y coordinate. And when we're moving forward, we increase the y coordinate. If we're moving back, we're going to decrease the y coordinate. the amount that we want to increase or decrease by, we'll take the speed and multiply it by the time. Speed times time is distance, and this distance is the change in distance that we want to affect the y coordinate. Same sort of thing here with the left and right arrow keys. When we press these, we're going to be updating the x coordinate. When we're pressing left, we want to subtract. When we're pressing right, we want to add, since to the right is positive x, to the left is negative x. And then same thing here, we take the speed, multiply it by the time to get the distance that we've moved, and then we update the x coordinate. Now if you have a physics engine in place, then this code will be a little bit different for you, but the general idea is the same. We have a function that we call to update the actual position of the car, and then when we render, we're using that position to place the car on the screen somewhere. Let's go try this out. Okay, so now when I click on the forward, back arrow keys, you notice that I can drive the car up and down along this road. The car looks a little bit big, so what I'm going to do is just quickly scale the car down a bit. Right before we call GL begin, just call GL scale F, and I'm going to scale it by 75% in both the x and the y coordinates. Let's go try this out. Okay, so that's a little bit better. The car now fits into one of these lanes quite nicely. So you can see using sprites and being able to control sprites with your keyboard is very powerful when you're trying to create a game. Notice that you can't see the white background of the texture image that I used to display this car on the screen. We're only rendering the car portion of the image. What else can I say? Oh, because this is a sort of simple demo, you notice that driving up and the street looks, pretty decent. However, driving left and right, well, that doesn't really make too much sense because cars don't drive this way. They would have to turn to actually, change lanes or whatever. So to make this a little bit more realistic, you might want to add the ability to rotate the car using GL rotate function calls. Or you could do what they did in the olden days on like Commodore 64 or Atari systems. There, whenever you had car racing games, you'd have this exact same scenario. You'd have a background rendered on the screen, and you'd have a sprite which you're controlling. However, to make things more realistic, what you can do is animate the background screen. Let's take a look at how we can do that. We want to change our code here inside of our GUI render function call. After we bind the texture ID for our background, we want to update the position of our texture on our quad that we're rendering to the screen. This quad basically fills the whole 1024 by 768 window, but before we render everything to that window using our texture coordinates here, we can do a texture transformation on the texture coordinates. So here I specify GL matrix mode GL texture. Notice that we've always been using model view up till now, but now I want to be transforming the texture matrix. So I specify I want to be using the model view mode GL texture. I'm going to push this guy onto the stack, and I'm going to initialize it to be identity. Now I want to move the texture only in the y coordinates system. So I'm going to create a static floating point number called fy, and I'm going to initialize this guy to 0. Then, every time we loop through this GUI render function call, I'm going to update fy by the time that has elapsed and some factor. So this factor is really the speed at which the image is going to roll in the background. Then I also want to do a modulo operation on this coordinate so that the value is always fixed between 0 and 1. And I can do that using the fmod operator. If you're not familiar with fmod, go take a look inside MSDN to read about how fmod works. But basically, it's going to take this number, divide it by 1, and whatever the remainder is, it's going to return back to fy. Then we want to actually perform the transformation, so I'm going to say GL translate f, 0, meaning I don't want to slide the texture horizontally, and then fy, I do want to slide the texture vertically. Then we go ahead, render everything the way that we did before, and before we call GL disable for GL texture 2D, you need to make sure you pop off the GL texture matrix that you popped onto the stack earlier right here. So don't forget to do that. And that's basically it. So now when we go and render our stuff to the window, see that the background is actually rolling on the screen. And now, as you can see, when I move left and right, it looks more realistic because it actually looks like we're driving down the road. You can control the speed at which the background screen is moving by just controlling that one parameter that I described up here. So right now it's set to 0.3. If you want to be driving really slowly, let's change it to 0.1. Now let's go give this a try. And notice that the image in the background scrolls much slower. So that's a very quick introduction to sprites and being able to control sprites. I hope that this video was helpful, and if you enjoy my tutorials, you can support the website by purchasing something from the store or by clicking on any of the Google ads found at the side. In the next VMK, what I'm going to do is show you how to generate and use animated sprites. Up till now, all of our sprites have been static of a road or a car like this. Well, in the next VMK, we're going to add animation to our sprites to make things look even more realistic.